Yes. Yesterday we were talking about significant figures, right? How many of
Yes,
you
sir.
took in the class in the evening? All right, let's start. Significant figure is used to calculate for the calculation and for the precision, basically. Okay, so I'm going to give a recap for those who are deaf. Basically, Akshay, are you present yesterday in the class?
Yes, sir.
In the
I was
evening?
there. Yes, sir.
I thought you missed. How many of you have missed the
No,
class
sir.
of?
I was getting disconnected, but I was there.
I'm just giving you a chance. Okay, so significant figures are basically the number calculation in the number. Why it is calculated, we will see. There are rules, and rules are rules simply. The rule number one says all non-zero numbers are significant. Okay, so all non-zero numbers are significant wherever they are, doesn't matter. Okay, all zero sandwiched between non-zero are also significant. Okay, trailing zeros are significant. Okay, leading zero are non-significant. And zero before decimal without any non-zero number is also non-significant. Okay, so these are some rules. Okay, so suppose I'm taking 0.00013000100. Okay, I have taken a arbitrary number. So this is trailing zero. This is sandwich zero. Trailing zero means after decimal, this will trail. Trail means after non-zero number, it will be trailing. This is called sandwich zero. This is called leading zero. Now this, to remove confusion, if there is a number in front of it, it will not be a leading zero. It will be a sandwich zero. Okay. So are you getting my point? I'm not asking to those who have attended the class yesterday evening. I'm just asking to those who thought it is better to sleep or have some fun rather than studying. Vaishnavi, why your
Yes,
camera?
sir. Sir, I'm joining from a different device today, sir.
What happened to your device, old device?
Sir, my laptop, it stopped working, sir. Some problem with the software. We have to get it checked, sir.
If you have something like in home, like if you have a computer, like do not use computer or laptop for video streaming for more than like 4 or 5 hours every day. Like if you keep streaming for 4 or 5 hours continuously, automatically the RAM will start showing problems. So that's just advice that after 2 hours of class, either restart the computer or just refresh it and delete all the temporary files. You know how to delete temporary files?
Yes, sir.
Just delete the temporary file, keep a fresh, restart it, it will be okay. Should not create problem. Unless you don't download Windows 11. Okay.
Okay, sir.
Rishi, Harshini, Akshit. Look, I can see those guys who have kept their video off are only those guys who didn't attend the class in the evening also. You have people to come to the campus. Why you have no idea, Shalini?
Sorry, sir, but mistakenly I've censored.
You're not permitted to chat. Let me change the settings. Okay. You can no longer chat in the class. Or no, let it be. I have allowed because people do need to ask question also. Don't do it. Okay. All right, everyone, look here. This is non-zero numbers are 3. So 3 is there. 2 zeros are sandwiched between them. And 2 zeros are trailing them. Right? After that, leading zeros will add nothing to the significant figure. So basically 3, 2, 5, 2, 7. Agree with me?
Yes. Yes, sir.
Yes, sir.
Sir,
Yes.
sir, could you repeat what the last zero was for?
For them.
Okay, sir.
1.234 is having 4 significant figure. 1.201 is having also 4 significant figure. 1.2 is having 2 significant figure. 0.012 is having 2 significant figures. Okay. 0.023 is having 2 significant figure. 0.200 is also having 3 significant figure. Suppose you have 56000. How many significant figures can be there?
Two, sir.
Make sure.
Oh, sir.
Two, sir.
Two. But it can maximum be,
Four.
we take 2, right?
Yes.
5.06 into 10 is to power 4. How many significant figures are there?
Three, sir.
Three, sir.
Here, how many significant figures in this?
5.
Three,
3.
3, 4, 5.
Four.
Agree?
Yes, sir.
Yes, sir.
So last one should be 3 no, sir.
Yes, sir. It should be 3, no, sir.
Hold on. Why it should be 3? Why it should be 3? Huh? Shrestha?
Rule number 4, sir. Trailing zeros are not counted without decimals, sir.
मेरी माँ ये 0 जो है ये 5.0 के बाद आता है.
Into 10 to power 4, no, sir. So it will become 50,600. That time only 3, no, sir. The last 2 zeros won't be counted because they're trailing zeros, sir.
Yes, but in that case, it's in our hand. Imagine 0, 0. Five zero 6 0. Here also it will be violated. Here also it will be violated. So when we change into a power, the thing changes. Power calculation is done differently. So this is basically why I am writing this, because I just wanted to show you that here exists only 2 significant figure, but I can write it up to 5. Okay, it depends on me how I want to represent it. Are you getting a sister?
Yes, sir.
56000 was the number I chose, and I did 2 significant figures inside it, but I said that maximum can be 5. So here I'm showing you that how maximum can be 5, at the same time how we can make it 2.
Yes, sir. I got it, sir.
Now we are moving towards the
Sir?
rules. Yes.
Then the second one, 0.200. Should we need to include the starting zero?
Why?
Even yesterday I got the same doubt, sir. 03, right? It include the zero before decimal.
Read. All non-zero numbers are significant. All zeros sandwiched between the numbers are significant. Trailing zeros are significant. Leading zeros are non-significant.
Okay, sir, got it.
Rules for mathematical operations. Okay. Addition and subtraction
The result is rounded off. Addition or subtraction, the result is rounded off to the last common digit occurring furthest to right in all component. Now I'm showing you something. We have 100, assuming maximum significant figure which can be 3, right? Come on.
Yes, sir.
Yes, sir.
Sir.
24.643. Okay. How much it will become? 124.643. Right?
Yes, sir.
Yes, sir.
How many significant figures are there?
6.
Yes, sir.
6. Round it off to 3.
124.6.
So when we'll round to 3 significant figure, it will become 125.
Yes, sir.
Yes, sir.
Come on. It's greater than 0.5 now.
Yes, sir.
Yes, sir.
Sir, so you took that significant figures for 100 as 3 for satisfying.
Maximum. If it will be 1, then
Always.
if you
That's
take,
all.
imagine if you take 1, what will happen?
Yes.
You will get 1 as answer, right? You add 124.643 and your answer will be 1. So it's
Yes,
not,
I got it.
that is why I'm saying that we should not ignore that thing, that maximum can be there. As we go inside the rules of the operation rules, it gets more and more clear to us that what exactly it means. How I am rounding it off, I will give you some rules, okay? Don't worry about it. Second, in multiplication and division, in multiplication and division, the result should be rounded off so as to have same number of significant figure as the component with least. Now least what? Significant figure. Okay. We're talking about in context of significant figure. So that is why we don't need to So let's take an example. Taking 3.0 into 12.60. Can you multiply and give me exact value? How much it is coming? 37.80,
80, sir.
80.
right? So if it is 37.800, you tell me the least significant figure was what?
Sir,
1?
Two.
Is it 1 or 2?
So it's 2.
Two, sir.
yes, sir.
It's 2.
2, sir.
Let me put it. And here we have 4. So how much we need? 2. So we need to write into two significant figure. So 37,
38.
8, we are going to round it
38.
off to write 38, right? Can you see the
Yes.
magic? So why we are doing this? To basically have an idea to avoid error. I imagine I am having 1039 divided by 2.0123. Okay. Can you give me the value after rounding it off?
I 6.3, sir.
51.
6.3.
6.3 after rounding it off.
Yes, sir.
Yes, sir. Everyone getting same? Yes, sir.
Yes, sir.
Rounding off rules. Okay. Rule number 1. If the digit to be dropped is greater than 5, the last retained is increased by 1. Okay, so suppose I am having 3.127. Okay, I am trying to drop 7, so I will add 3.13. Okay, so I am retaining this number. I will add +1 into it. Getting it?
Yes,
Come
sir.
on. What is the second rule? If it is less than that, then it will be left alone. Last retained number will be left alone. Can you write by yourself? So suppose 3.124 was there. We'll write this. If we are dropping this, we'll add 0. So it will become 3.12 only. Come on.
Yes, sir.
Write the second rule by yourself. Third rule. What if the drop digit is going to be 5? Anyone? Anyone?
Increase by 1.
We should increase one.
Sir, if even retains, if odd increase by 1, sir.
Come again.
If even, then same. If odd increased by 1, sir.
Suppose I'm having 11.5. I have to drop this 5. What I should write?
12, sir.
12, sir.
12, sir. 12, sir.
And if I write 12.5, if I have to drop this 5, what should I do?
12, sir.
13.
13.
1, sir.
12, sir.
So if it is odd, you will add +1. If it is even, you will do nothing. So write it down in the words. If the digit drop is 5 and it is followed by 0 only, last remaining digit is increased by 1 if it is odd. And left as it is if it is even.
Sir, I have a doubt in multiplication of significant figures. So in one question I have a doubt, sir.
Now it will come to that. Okay. So let's practice some more problems. Okay. So 24 into 3.28. Find answer in this best as per your knowledge. So this will become what? 78.72. Here we have 2. Here we have 3. So answer must be in the two significant figures. So it will be rounded off. 7 will be adding to this 78. It will become what?
79.
79.
Everyone getting the same answer?
Yes, sir.
Yes, sir.
Yes, sir.
This is going to be what? 28.2.
28.
Now this is
28.
2 significant figure. This is 3. So now we need to round it off into 2 significant figure. This is 2. So there will be no change here. So it will be 28. Now this division will lead to 2.995, I think. So 2.995. Again, here we have 3, here we have 3, so we can take 3 significant figure. But 5 will have to go. So this 9 is odd. So it will become 3.00. Agree with me?
Yes.
Yes, sir.
Yes, sir.
Isn't it beautiful? Come on. Say yes.
Yes, sir.
Yes, sir.
Yes, sir.
It is. Look through my eyes. It is. Solve this 2.8723 into 1.6.
4.6.
But it is
4.6.
4.6. Everyone getting same? 4.6.
Yes, sir.
Yes, sir.
Good. On 3.0 into 10 is to power 4 and 1.15 into 10 is to power 4. Okay. So what we have to do, divide it.
Two point six is 10.4.
2 point.
6 into 10.4.
Good. We need to take minimum significant figure, that is 2.
Sir, how 10 to the power 4 will come, sir? There.
It will be cancelled.
Yes.
Yes, sir.
Yes, sir.
Mistake. Okay. Forgive me. I am sinned. Okay. Will you do that? Everyone knows that 10 is to power 4 will not come. Come on. Change it. Is it that big issue? 3.512. Solve some more problems. Now I'm giving you collective all addition, multiplication. 12.3 divided by 2.82. 1.48. 8.4. 0, 0, 0, 0, 2, 8, 6.
Answer.
Done, everyone?
Answer.
All right. First,
5.28.
5.28.
okay.
0.436.
It's 4.4, sir.
4.362.
4.36.
We need to have three significant figures. 4.36,
Yes,
1.4,
sir.
8.4.
12.
12, sir.
0.00286 divided by this number. Come on, how many significant figures are here?
5.
5. And how many will be here?
Sir, 0.684. Is the answer.
Yes, sir. 0.684, sir.
0.684.
Sir, there are only 3 significant
Yes,
figures.
sir. Yes, sir. 3, sir.
Here it is 3 only. Okay, so now let's talk about precision. Okay, so what is precision? How precisely you measure something, up, that is called precision, right? How correctly you measure. So if you measure something, suppose that in a laboratory you are measuring a certain mass, every time when you will measure, the values will not be same. So 3 times when you will measure in the lab, the values will be different. So what we do, we take average. When we take average, what we do, we try to avoid the error, uncertainty. Okay, so precision is that last digit. When you are trying to calculate something, how correctly you are calculating the last possible digit appearing in the calculation. Okay, suppose that I'm having 6.287 ml. So our precision will be at the 7 ml because this is the thing which can get us the error. Are you getting my point? Think about it. If the error will come, if it is not instrumental error, it will be only because of this 7.
Yes,
Come
sir.
on. Think.
Yes, sir.
So write it down. Degree of precision gives us nearest possible value
Could you repeat it once?
degree of precision gives us nearest possible value in such a way to minimize the extent of error. So suppose I'm having a value 10.74. How many significant figure it do have?
4, sir.
4, sir.
4.
Yes.
Which digit is uncertain? 4.
4, sir.
4, sir.
10, sir.
So sometimes they will ask you that why find the uncertain digit. Always remember, it's not a big deal. We can always find uncertain digit. Okay. We can always find the uncertain digit just by looking at the number. When we calculate significant figures, we try to avoid or minimize the uncertainty in the digits. Okay, to get more precise value so that we can minimize the errors resulting in the laboratory calculations. Okay, so this significant figure is basically used for the laboratory calculations. All right, guys. So, what you do, you have your book, right? In which this chapter is given.
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Solve all the problems for this week, and let's meet at 4:45. Okay.
Yes, sir.
Okay, sir.
You
Yes,
must
sir.
be here by 4:45 because 5:30 I will end up the discussion. Okay. We will discuss the problems today. So by 5:30, I told you yesterday I will have to rush up. Okay. Because I need to discuss the paper by 6 o'clock. And every day there is a paper. So 4:45 to 5:30, everyone be present. Okay. See you in evening. Okay, all right. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Take care, everyone.